Hi everybody. Today we're going to be reviewing everything that we've learned about trigonometry up to this point so we can get ready for our quiz. The first skill that we're going to review is finding trig ratios of the given angle. The directions from 1 to 4 ask us to round to the nearest 10,000th, which is 4 digits past the decimal. Now remember that all of this is based on SOHCAHTOA, and that's given up here, SOHCAHTOA. Remember that what this really means is there's an equal sign between the sine equals the opposite over the hypotenuse, the cosine equals the adjacent over the hypotenuse, and the tangent equals the opposite over the adjacent. So if they ask you for a cosine of something, you need to go up to this c equals a over h, and just plug in the numbers. So we'll say cosine of c equals, and we know it's the adjacent over the hypotenuse, but we haven't labeled anything yet, so we don't know what numbers to plug in. Let's go ahead and label. The right angle always points to the hypotenuse. The angle that we're talking about, they want c. C is always sandwiched between the hypotenuse and the adjacent, and the remaining angle is opposite. So if we're looking for a over h, that would be 36, which is a, over 39, which is h. So 36 over 39. And in this problem, you only have to do the division. Take 36, and the fraction sign means divide. So divide 36 by 39. And you will get a decimal. You are rounding to the fourth digit beyond the decimal point, so it would be 0.9230. So the cosine of c equals 0.9230. Now, just a word about the computer format that you guys will be working in with your quiz. Your quiz will want you to put the 0, if it's a 0, before the decimal point, and it will want 4 digits beyond the decimal point. So if they end up being zeros, you need to fill in zeros until 4 digits are taken off. For example, I could have written that number is more quickly written as 0.923, but for the computer to be happy with what you do as you take your quiz, you'll need those zeros right there, something before the decimal point, and make sure you fill up everything beyond the decimal point. Okay, all right, let's look at number 2. Number 2 asks for the sine of c. Here's our angle c that they want again. Hypotenuse directly across from the right angle, adjacent is on the other side of the angle, and then opposite is the angle farthest away. Sine needs opposite over hypotenuse. So the sine of c equals the opposite, 21 over the hypotenuse, which is 29. 21 over 29. And we can come on over here, clear everything, and 21 divided by 29 is going to equal 0.7241, and the 3 is not enough to make that one round up, so it really is just 0.7241. Okay, so sine of c equals 0.7241. Okay, now let's look at number 3. Your tangent of c is what they want right now. So tangent of c, the c angle is right up here now. It's not that angle on the bottom left. So it doesn't matter. You still start with a hypotenuse, make it be that side that's directly across the right angle, so there's the hypotenuse, and the angle is always sandwiched in between h and a, and then the other one is o. Tangent means the opposite over the adjacent. So the tangent of C is going to equal the opposite, which is 27, over the adjacent 36. 27 over 36. And that just needs a little bit of calculation over here. So 27 divided by 36. And that is 0.75. So the tangent of C equals 0.75. Now that's a nice terminating decimal. It ends, but remember, if you want your quiz to be marked correct, the computer will only understand it if you fill out 4 digits beyond the decimal point. And so that 0.7500 would be the answer that you actually have to write. Okay, I'm going to let you work on number 4 alone because I want to see if you can do it independently, but there's been a lot of help for you. Let's come on over here and we'll go down to number 5. Number 5 starts a new skill. We're going to be finding the value of each trigonometric ratio to the nearest 10,000th. Now it's only a new skill in that you get to now use your trig function buttons. So this can go right into the calculator. Not a whole lot of extra thought or setup. You can just put it right in as cosine of 60 and it will give you a decimal. Now that decimal, just like we talked about in the others, if you set it up as 0.5 or just 0.5, numerically, technically, you're right, but for the computer to understand you, you need to fill out 4 digits beyond the decimal, and so it's 0.5000. There's your 4 digits behind the decimal. Okay, let's try another one. 62 degrees. Sine of 62 degrees. Come on over here. You can put this right in the calculator and hit sine of 62. Sine of 62, 0.88294. The 4 is not enough to kick that 9 up and go to the next higher rounding, so you just keep it. So the sine of 62 is 0.8829. Okay, and that's all there is to that skill. Next, we get to look for the missing side, and the directions are rounding to the nearest tenth. So what that means is that if we were had a decimal point, we just want 1 digit beyond the decimal, that's all. So if we had a 0.59, that 9 would be enough to round that up to 0.6, so you'd have to put in 0.6. And in these, you're not talking ratios, so you don't have to plug in zeros after and have 4 decimal places. You're only rounding to the nearest tenth, so you only want 1 place beyond that decimal. Okay, now let's get to the skill of finding that x. We have to remember our SOHCAHTOA, so I'm going to write it here because I'm not looking at it anymore. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. SOHCAHTOA. Let's mark the angle they gave us. They gave us 53 degrees. So with that given, let's mark our sides. Hypotenuse is always right across from the right angle. Sandwiched in between the adjacent and the hypotenuse is the angle, and the opposite is always the farthest side away. You can see that we have something given for A and O. We don't have anything given for H, so we don't really need it. And I'm going to go look up here at what trig function only uses O's and A's. And if I scan across here, what uses O's and A's is tangent. So I'm going to go tangent of, and right after the trig function is always the angle. tangent of 53, is equal to the O over the A. The O is the X, and A is given as 12. Now remember that this means divide, and when we're solving any equation, if we want to get this x all alone, we have to do the opposite of what's being done to that x. We're dividing away that 12, so if you want to get rid of it, you have to multiply times 12 on this side. And we'll do the same thing and multiply the left side by 12 also. That'll let us cancel those 12s and get x all alone. And then this is what we're putting into our calculator, 12 times the tangent of 53. You don't need to write the times right before the tangent because the computer will understand you. So we're just going to go 12, and then we need the tangent of 53. Okay, now if we're rounding to the nearest tenth, we've got 15.92. Now we really only want that 9, and we're asking if the 9 can go up, and it can't because the rule is 5 or bigger can make it go up, but that's only a 2. So 15.9. So x equals 15.9. Okay. All right, that one's done. Let's go label our sides on number 8. Hypotenuse is always directly across from the right angle. The angle that they gave us, it's always good to mark this so you know and you don't get confused. But there's always hypotenuse on one side and there's always adjacent on the other side of the angle that we're looking at. And the side farthest away is the opposite. In this case, we don't need A because there is nothing given, no value or no variable to find on that adjacent side. We do need O's and H's. And if we look up here and scan, we see that sine needs O's and H's. So it's the sine of the degrees. The degrees are 59. So sine of 59 equals x over 17. And now this looks to solve just like the one before. We're dividing by 17, so the opposite is to multiply. We're going to do that same thing, multiply by 17 on both sides. Multiplying by 17 lets us cancel out that 17 that's dividing below there and get x all alone. So now we're going to put in our calculator 17 times sine of 59. And that'll give us 14.5, and there's a 7 there on the second place after the decimal. The 7 is bigger than 5. It's 5 or bigger, so it can let that 5.5 round up to 0.6. So the rounded to the nearest tenth here would be 14.6. Okay. Let's leave this one for you to do independently. Do number 12. You can always email me with questions if you're confused. Let's go look at number 10. 10 gives us a slightly different skill where we're not finding a side length, we're finding an angle. And remember that we needed to use the inverse functions to find angles. So it looked like on our calculator sine with a -1 over it, and cosine with a -1, tangent with a -1. But we say that inverse sine or inverse cosine or inverse tangent. It's good to remember, again, the SOHCAHTOA. So I'll just write that real fast up here. So we can set our problems up right. We do need to always start by labeling the sides. Hypotenuse is always directly across from that right angle, so there's H. The angle that they're given is the one that they put an arc by and put a question mark by. We need to find that. That angle, even though they didn't tell us what it is always sandwiched between the hypotenuse and the adjacent. So it works the same way as before. The farthest side away from the angle is the opposite. And it looks like we don't even need the opposite because there's no value given here. So we have A's and H's. If we look and scan, the one that uses A's and H's is cosine. So we're going to say the cosine of, and if I don't know the angle, I will just say it's x. The cosine of x equals the adjacent over the hypotenuse, or 24 over 36. Now, we almost have that x all alone, but we need to get rid of that cosine. And the opposite of cosine is the inverse cosine. So we'll put cosine -1 up here. And if we do it on the left, we have to do it on the right too. And that lets us cancel the cosine and gets our x all alone. It also shows us how to put everything in the calculator. You're going to put in the inverse cosine first, and then 24 divided by 36. Remember that our inverse cosine and all of our inverse functions are here in the extra functions. And we can find that inverse cosine. And then we do have to go back to get the numbers in the main menu. And it's 24 divided by 36. Okay. Now in this we are rounding the directions, say round to the nearest degree. So you don't want anything after the decimal point except a 0. You're looking though at that 1 that's right after the decimal, and we're saying, is it enough to round up? The rule is 5 or bigger can let it round up. This one is, of course, not 5 or bigger, so it can't round up. This is just 48.0. So x equals 48.0, and you do not have to put the degrees. Okay, good. Let's go look at number 11. Again, we start by rounding, by labeling the sides. Hypotenuse is across from the right angle. Here's our angle that they want us to solve for. It's always sandwiched between hypotenuse and adjacent. And the O is the one that's farthest away. It looks like, again, we didn't need that O value. We need A's and H's, so we're going to use cosine again. We're going to say the cosine of the angle that we don't know, so we'll say x, is adjacent over hypotenuse, just like it says in our key up here. The adjacent number 24 goes above the 36. Oh, wow. Hey, guys, looks like I have one exactly the same. Well, bonus. Go over here and look how to solve it. Wow. All right, I must have been tired when I made that one. All right, let's look at 12. This one definitely looks different. We do need to solve this by finding our hypotenuse. And there's our angle that we don't know. Its other side is going to be the adjacent, and the side that's farthest away from the angle is opposite. Okay, now this one, we need to look at the ones we don't need first. You don't need hypotenuse because there's nothing given there. So we look and we see which trig function uses O's and A's. O's and A's are used by tangent. So we're going to write the tangent of the angle we don't know, so x. The tangent of x equals the opposite, the 13, over the adjacent, which is, in this triangle, 45. How we get that x alone is to get that tangent gone. So the opposite is the inverse tangent. And we'll do the inverse tangent on the right-hand side too, so we keep our equations balanced. And x equals, we can do this in our calculator, the inverse tangent of 13 divided by 45. Okay, so again, we're rounding to the nearest degree. This will be 16 point, and we look at that 1. It is not enough to make the 16 round up to the 17. So it's just 16.0. And you're done there. Okay, go ahead and see if you can do 13 on your own. Okay, these are just like what you did before, except you don't have to set things up. The only thing you have to remember is that if you want to get x all alone, you need to get that sign to go away. And we know that the sign opposite is the inverse sign. So inverse sign will make that go away, but anything we do to the left-hand side, we do to the right-hand side as well. So x is going to equal, and let's go over here. Go to functions, go to the inverse sign, and then we're going to put in that decimal just like they gave it to us. So we'll go 0.7547. And that is approximately equal to 48.9 degrees, but we're supposed to round to the nearest degree, so that 9 is enough to make the 48 go up to 49. So this will be 49.0 degrees. And again, in the computer, you do not have to try to figure out how to write a degree sign up here. Just the 49.0 is just fine. Okay, look at number 15, try that on your own. And let's go ahead and talk about some word problems. These trig functions are very useful in everyday life. There are a lot of applications for this in lots of different fields of math and engineering and other sciences. Here's an example. An airplane is flying at an altitude of 6,000 meters over the ocean directly toward a coastline. At a certain time, the angle of depression to the coastline from the airplane is 14 degrees. How much farther to the nearest kilometer does the airplane have to fly before it is directly above the coastline? So one of the best things you can do for yourself is to draw a diagram or a little picture. So here's my airplane. I'm not going to try to be an artist or anything, but here's my airplane and it's flying and it's over the ocean and it's coming to a coastline. We'll say there's its coastline, the starting, and here's the ocean. Okay. The angle of depression would be if I were looking straight ahead. How much would I have to look down to find a point that I was aiming for? In this case, what I'm aiming for is the coastline. Can you see that if I would look straight ahead from the airplane, I'd have this straight side, and then you'd have your right angle as you would go directly down to the coastline. You would have your hypotenuse as you would look across and down to the coastline. So you can see you've drawn a triangle. And let's see how we're going to label that. An airplane is flying at an altitude of 6,000 meters. Okay, that means if it's over the ocean directly toward a coastline, this is how high it's going to be, and it's 6,000 meters. Okay, at a certain time, the angle of depression, so at this time, the angle of depression, that means how much I'm looking down, is 14 degrees. How much farther to the nearest kilometer does the airplane have to fly before it is directly above the coastline? That doesn't mean it's going to start its descent right now. It won't start its descent till later. All they want to know is how far until they hit the coastline. So you're really looking for this top straight line as you would look out from the pilot's seat, going straight across the horizon. That's our x, and that's what they want us to find right here. So this is like one of those familiar problems now. We're just solving for a missing length. We can label our sides. There's our hypotenuse. Hypotenuse and adjacent sandwich that angle, so there's the adjacent. and the farthest away from the angle is the opposite. We don't need the hypotenuse. We're not looking for it, and they didn't give us a value for it. So we just want A's and O's, which we know O's and A's make TOA, or tangent. So that's the tan of 14 degrees equals x over 6,000. Okay, we've done lots of problems like this, so I'm going to circle this one for you, and finishing this one after we've set it up is part of your assignment. Let's go look at 17. Number 17 says a 9.0 meter ladder rests against the side of a wall. The bottom of the ladder is 1.5 meters from the base of the wall. Determine the measure of the angle between the ladder and the ground to the nearest degree. So let's draw our wall. Buildings are generally straight up and down, and ladders usually lean. So here's my ladder, and again, I'm not going to try to be a great artist, but just to draw something that kind of looks like a ladder so you know what I'm talking about. The ladder is 9 meters, or 9.0 meters long. The bottom of the ladder, okay, the bottom of the ladder is that distance from the bottom to the ground. The bottom of the ladder is 1.5 meters from the base of the wall, so this is 1.5. Now generally the ground and a buildings are straight up and down, so they generally form right angles. So there's our right angle. And let's look at what they want us to find. Determine the measure of the angle between the ladder and the ground to the nearest degree. They're not asking you for how big this side is. They're asking you for an angle. Angles are these little corners. And it says between the ladder and the ground. Here's the ground, here's the ladder, here's the angle they want us to find. That's our x. So this is one where you're going to need to use the inverse functions. We still set it up the same way though. Going across from the right angle, we label that as our hypotenuse. And the angle is always sandwiched between the hypotenuse and the adjacent. This side that tells you how far up the wall it's going, that's our opposite. But like I said before, you don't even need to know that. They didn't ask that. So now we're going to say what uses A's and H's, and we know from practice that that's cosine. So we're going to say the cosine of our missing angle, so x, equals adjacent over hypotenuse. So it's going to be 1.5 over 9.0. We know that we can get rid of our cosine by going inverse cosine on both sides. And I'm going to leave this up to you to figure it out and let me know what the answer of that is. You may have a word problem just like one of these on your quiz on Thursday. So make sure you read through these and understand the diagrams that I've drawn for you. Okay, good luck guys. Email me if you have any questions.